Okay, I am starting on page 5 here for some notes. We're going to go up to the top where it says example 3. This is a little bit with multiplying here. We're going to get more into multiplying later this week, but I do want to show you this one example here. And then we're going to do with what do I do if there are variables under that square root. So when I look at example 3 here, it says simplify the square root of 2 times the square root of 14. Well, we learned yesterday the opposite of not the opposite, but reverse of this rule. So the rule yesterday said if two things were multiplied together under one square root, we could break them apart into two square roots. Well, that equal sign means it goes both ways. So what that means is if there are two things being multiplied separately, you can put them together under a square root. So these two are being multiplied separately. So I can put them together under the square root and make that 2 times 14. Now we have two options there. We can do 2 times 14, which is 28, and then break that down. Or since 2 is already prime, we can break down 14. I think it'll keep most of you straight better if we multiply those two together to get the square root of 28. And then I can do my factor tree for 28. So that is 2 times 14 and then 2 times 7. So that would be 2 times 2 times 7. I have a pair of 2's that met at the singles mingle. They get married, and then just the 7. Please remember when that pair of 2's goes out front, we only write it one time because 2 times 2 is 4, and the square root of 4 is 2. That is why this works, because if we take the square root of 2 times 2, it is just 2. So if they're broken apart separately, you can put them together and then simplify it down. But now let's go to example 4 on this page. This has variables. We haven't done any with variables yet. So the first thing I want you to realize is that the number part is the same. So we're going to start with breaking down the number part first and then look at the variable. So for the number part, I'm going to do the factor tree for 90. If you like the other method where you get the perfect square that goes into it, you can start there. It'll get the same answer. But this is 9 times 10 for me, and I could see that perfect square there. 9 breaks down into 3 and 3, and 10 breaks down into 2 and 5. So when I start this square root, I've got a 2, a 3, a 3, and a 5. Now this next part, for this one example, I'm going to have you expand everything out. And then I'm going to teach you a shortcut. If the shortcut does not make sense to you, then you need to go with the expanding everything out. The expanding everything out is not super difficult. It just does take a little bit of writing, and we know most of you try to write as little as possible. So x to the third means x times x times x. And y to the fourth means y times y times y times y. And z to the fifth means z times z times z times z times z. Now I know you do not want to write all that out every time, which is why in just a minute I'm going to show you a shortcut, but I want to show you why the shortcut works. It's really the same thing, just a little bit faster there. So I've got to break these up into pairs. So I see a pair of 3's, a pair of x's, a pair of y's, another pair of y's, a pair of z's, and another pair of z's. So I'm going to bring that pair of 3's out front as 1 3 because 3 times 3 is 9 and the square root of 9 is 3. I'm going to bring that x out front. I'm going to bring the y and then another y because there were 2 pairs of y's, and then the z and another z because there were 2 pairs of z's. And then everything that I did not bring out front, I'm just drawing these lines to show you where they came from. You don't have to draw these lines. But everything that didn't have a pair was 2, 5. There was 1 x that did not have a pair and 1 z that did not have a pair. So now I need to rewrite that so it looks a little bit better. 3x y squared z squared, because y times y is y squared, z times z is z squared. And then under here, 2 times 5 is 10x z. Now, there is a rule about absolute value, and we're going to deal with that later. But for now, let's just put a disclaimer on here saying that assume all the variables are positive. Because on the con you're going to do today, it assumes all the variables are positive. If all the variables are not positive, we have to bring in absolute value. But we'll talk about that another day. No need to overwhelm you. So this would be my answer. Now, I told you I was going to show you a shortcut about the variables, and I am, but I want you to notice something. When you finish this, the letters that are left under the square root should not have any exponent other than 1 unless there's a fraction. We'll deal with that later. But the reason it can't have anything higher than 1 is because if it did, there would still be a pair left under there. So all of these should be to the first power that are left under there. So I want you to know if you write it out like this, the pairs will always work. But you don't want to do that. What if it was z to the 37th power? You would not want to write out 37 z's. So let's go down to the bottom where I've got some fill in the blanks for you. It says for variables, if the exponent on the variable is even, divide the exponent by 2, and that exponent goes in front of the radical. So I'm going to take that first sentence and explain what that means. So let's look up here at the top. Were any of these even? Yes, y to the 4th power is even. So what this is saying is if there's an even exponent, you can divide that by 2. What is 4 divided by 2? 2. And whatever you get, you put that as the power on that term in front of the square root. So look here, when we did this, y squared is what went in front of the square root for the y. So if you ever have an even exponent under the square root, all you got to do is divide that by 2, and that's what goes out front, and nothing is going to be left under that square root because they were all pairs. They all met somebody at the singles mingle because it was an even number. But if it's odd, there's going to be an odd man out, someone who is left, like the x and the z here. They both have odd exponents. So what do we do if it's odd? So let's go to the next sentence. If the exponent is odd, subtract 1 from the exponent, because that must stay on, that 1 must stay under the square root. That 1 that you're subtracting, he is the one left at the singles mingle that didn't find a partner. That's why we're subtracting 1. Then divide the exponent that's left by 2 to find the exponent that goes out front. So let me show you here with this 5. If we just had z to the 5th here, if that's all I'm looking at, that is an odd exponent. I subtract 1. What is 5 minus 1? 4. After I subtract 1, the reason I did that is because that 1, the odd man out, he is going to be stuck under that square root. So I'm now taking that 1. There are 4 of them left. I divide that 4 by 2. 4 divided by 2 is 2, and that goes in front because dividing by 2 tells me how many pairs there were. So subtract 1, put that under the square root, that 1 that you subtracted, and then whatever's left, divide that by 2, and that goes out front. Let's check it with the x to the 3rd. With the x to the 3rd, if I subtract 1, that 1 stayed under the square root, and that leaves me with 2. What is 2 divided by 2? 1. So an x to the 1st power better be out front, and it was. So we need to practice another one of these. I hope you could see that. Pause here if there was something you couldn't see and need to fill in. But going back to the page that we were doing in the video yesterday, which is page 10, let's do number 19 on page 10. Number 19 on page 10. It says the square root of 150, a squared, b squared, c. So the first thing I'm going to do is break that 150 down using the factor tree method. So that's 15 times 10, 3 times 5, and 2 times 5. So I put those under the square root, a 2, a 3, and 2 5s. Now for now, I'm going to leave the letters. If you want to expand out the letters and do the pair thing, that works. You can do it. But I'm going to show you with my new rule here. So the 5 goes out front as a pair. The 2 and 3 are left under there. This a squared, is 2 even or odd? It's even. So I'm just going to divide it by 2. What's 2 divided by 2? 1. So a to the 1st power goes out front. Again, we'll deal with the absolute value later. Then I look at b squared. That's even. So I just divide by 2. 2 divided by 2 is 1. So that goes out front. C is odd. c to the first power. Well, there's only one of them, so that 1 has to stay under there. So this is 5ab times the square root of 6c. Let's do one more. Let's look at number 20, and we will stop with these videos, and you can work on your cons. So the square root of, or this video, 72a to the 6, b to the third, c squared. This is number 20 on that same page. So I'm going to start by breaking down 72. 9 times 8, 3 times 3, 2 times 4, and 2 times 2. So under the square root, I got 3 2's, a 3, and a 3. If I'm ever going too fast, please pause and write down what you need to, and even rewind if you need to. The letters I'm going to leave with the exponents for now and deal with that on the next step. So there's a pair of 2's and a pair of 3's that go out front. That 1 2 is left under the square root by itself. Now I'm dealing with the variables. A to the 6th power. 6 is even. So if I drew out 6 A's, that would be 3 pairs. Or I could say, okay, it's even. What is 6 divided by 2? That's 3. So out front, I'm going to put A to the 3rd. B to the 3rd, that's odd. So I'm going to subtract 1, and that 1 has to stay under the square root. So what is 3 minus 1? That's 2, and 2 divided by 2 is 1. So that one goes out front. And you got to think, if I drew out 3 B's, one of them would not have a pair, 2 of them make a pair, and that pair goes out front. C squared, that's even. 2 divided by 2 is 1, so that 1 goes out front, and nothing is left under the square root. 6 a to the 3rd bc times 2 square roots of b. I am putting a disclaimer here. We do need some absolute value signs. We'll do that in a different lesson. I do not want to overwhelm you. For now, let's just assume all variables are positive. So now you need to go do the con that includes simplifying with variables.